Synthesis in alkenes through dehydration of alcohol. The purpose of this experiment is to synthesize two isomeric types of methylene cyclohexene via acid catalyzed dehydration of 2-methylcyclohexanol. Here we have a general equation of what happened. We have our substrate with alcohol. We applied heat in an acidic environment. The alcohol is lost along with a hydrogen, and a double bond is formed between two carbons. The two chemicals that were used were 2-methylcyclohexol, which served as a substrate, and phosphoric acid, which provided the acidic environment. We took a small amount of 2-methylcyclohexanol and phosphoric acid. We mixed it, we heated it, applied a lot of heat. It evaporated, the solution evaporated, it traveled into the condenser, recondensed, and we collected a small amount of our distillate. After that, we dried it and ran a TLC on it. Here we have a more specific equation of what occurred. Phosphoric acid supplied the hydrogens. We applied heat. We have our substrate, which then, through several different steps, yield different products. In this case, 3 were possible. Regardless of what the final product was, these were the first initial steps. First, we have the proton transfer, where hydrogen is transferred to the alcohol in the substrate, which forms the water connected to the substrate and forms water. Second step is water loss. Since water is a good leaving group, it's going to take the electrons that are shared between the ring and the branch, and it's going to form water, and we are going to be left with the second degree carbon cation. From here, several steps could occur. We could either form a double bond here, and we could have a hydride shift. We actually have a hydrogen here, but I didn't draw it in. However, we could have this hydrogen shift over here, which is going to form a more stable carbon cation. A tertiary one, which would be more likely to happen. So here in the next slide, we're gonna go through the steps that could occur. So here we have the less likely route that the mechanism will take, because it will yield the minor product. The double bond it's gonna form here, so water is gonna act as a base and remove that hydrogen, which then it's gonna form a double bond here and acid. This is highly unlikely because, first of all, we could form a more stable carbon cation, and second of all, according to Setsev's rule, the hydrogen that's going to be removed is going to be the one connected to the carbon that has the least hydrogen, which would be this one, which only has 1, and this one has 2. So here's one of our products that could have happened throughout the reaction. Another route that could have been taken, like I mentioned earlier, is the hydride shift. This hydrogen would have shifted over here. Transitional state would have occurred where the hydrogen is moving, and then it would have formed a third degree carbon cation, which would be more stable and would be able to form a double bond here, or here. Whether it forms it here or here doesn't matter. It's gonna be the same thing because of the orientation of the atoms in space. So this reaction here is gonna yield the major product, which is gonna be the more likely scenario or mechanism that could occur. Water again is gonna act like a base, remove this hydrogen. Then electrons are gonna be shared between these two. A double bond is gonna be formed here. And like I said, this is following Setsev's rule, which the hydrogen that's gonna be taken is gonna be the one from the carbon that has the least hydrogens, which in this case would be this one or this one. They have the same amount too. However, it would not be this one because it has 3. So we have this as our major product. So again, here we have the tertiary carbon cation that was created with the hydride shift. And again, like I said, instead of taking one from here, which is likely to happen, the reaction could have taken a hydrogen, or this water could have taken the hydrogen from this carbon, and then a double bond could have been formed here. But this is unlikely because it goes against set flow. So our different products could have been this double bond here. Sorry about that. This double bond here, this one here, or both are minor, or this one, which is a major. The way we were able to determine this was through TLC. We put our sample, we dabbed it on the line here. We let the solvent move up the TLC. As the solvent moved up, it would pull less polar products higher up, and we will have different levels of where the solvent stopped depending on the polarity. Here are my results, which do not correlate to what the theory says. Here we have I only got 2 dots, which is not what we expected, since there were 3 possible products. I compared my results to one of my classmates, and they actually got 3 different dots on the TLC. As we can see here, we have 1, 2, 3. It was ran twice just to verify 1, 2, 3. And so it proves that yes, 3 products are possible to form in this reaction. Thank you.